In this problem, they give us rhombus ABCD. Angle CDA is 60 degrees, and it says that a circle passes through points D, A, and B. So let's draw this rhombus. Here we got A, B, C, D. And they say that CDA is 60 degrees. So that means this is 60 degrees, this is 120, this is 120. All right. Now the key thing with this is that C turns out to be the center of the circle. Now you ask, how can that be? Well, AB is a chord of the circle, and the perpendicular bisector of this chord passes through the center. And so here, these two perpendicular bisectors have point C in common. So what we're going to do is we're going to call BC R, and CD, we're going to call that R. Because what we need to do is determine the probability that the point selected inside the circle is also inside the rhombus. So what this is a probability problem where we compare the area of the rhombus to the area of the circle. So the area of the circle is just pi r squared. But the area of the rhombus, we've got to break that down a little bit. So the rhombus is really just two equilateral triangles. So here we have R, R, 60, 60, 60, 60, and 60. And if we take an equilateral triangle and break it in half, we get R over 2, R over 2, and then we have R squared of 3 over 2. So the area of this triangle is 1/2 the base, which is R, times the height, which is R squared of 3 over 2. Now the thing to remember is that's the area of this triangle, so we need to double that to get the area of both of them. All right. So this 2 and this 2 will cancel, but this 2 will remain uncanceled. So we have R squared, square root of 3, all over 2. So now we have to compare this probability, this area, to that area. So we take R squared, square root of 3 over 2, and divide by pi r squared. Now we can cancel the r squareds. And so that can simplify to square root of 3 over 2 pi. However, it says we want our answer as a decimal. So we'll reach for our calculator and take square root of 3 and divide it by 2 pi, remembering to put 2 pi in parentheses. And so we get 0.2757 because we're rounding to 4 significant digits. And there's our answer, and we're done.